So, welcome everyone in the second part of the webinar. So, here we are going to discuss about the repair methodology of civil engineering works. So, in short, I want to tell about this module, this part. Here we are going to see some of the causes, the main causes, and some of the prime causes that induces these types of repair work, and which makes a concrete structure or even steel structure gets deteriorated. So it's very important to know the cause for which a structure is going to experience distress. It may be of different reasons. So we'll have a brief discussions on some of the reasons of deterioration of concrete structures as well as steel structures. And then we'll see some of the repair methodologies, some new technologies and some repair methodologies in short, because it's a full subject. It's a subject, so it's not possible to complete the whole the things within 1 hour or some limited time period. So here in this part, in this webinar, we'll see some of the prime and most common causes how a concrete structures get failed, or how a concrete structure needs repair, why it needs repair. That is most important. We have to know the reason behind it, and how we used to do some of the repair work. So we'll see all those things in this webinar. So this whole lecture is divided into two parts. First part, we'll see some different reasons of structural deterioration, and in the second part, we'll see about some repair and strengthening as well, some repair and strengthening techniques. So here I want to mention one difference. The main thing is that repair and strengthening techniques. I have mentioned the second part is repair. So repair and strengthening is not same. The repair means when a structure needs some maintenance or some work, some little work when a structure needs to regain its original that condition is known as repair. And strengthening is something like when a structure is not able to get, when a structure is not possible to get the original state after doing some repair. At that time, we need to provide some extra strength to the structure for long life. This is known as strengthening. So repair and strengthening is not exactly the same work that we do in construction site. Repair is something, repair is coming under maintenance part of concrete structure, where strengthening is not maintenance. Strengthening is when the maintenance of period is over, it needs some extra strength to take the upcoming loads or the load which is experiencing already by the structure. So we'll see all those things in the second part of this lecture. So India is witnessing a construction boom. So you can see that the highways, that seaports, airports, lot of different types of construction, what is happening across our society, around our society. It's really a boom construction. And then we are also having a scheme from the government, housing for all, and all those things. You can see the pictures on the slide, on the presentation. You can see the different the things that I have given. The structures are more or less somewhat important structures. If you see the below right, I don't have any pointer with me, so that you can see I think you are watching my mouse point. So you can see these types of structures. So it's a structure in Chennai, hope so. And these types of structures needs that very good repair work if they face any repair work. So it's very important to ensure that when we used to construct some important structures such as metro constructions, flyover construction, bridge constructions, dam constructions, even that multi-story building construction. So whenever we used to construct these types of important structure, it's quite important to maintain the durability of the structure. So durability means that for a long time, that persistence, long time that the structure should be stable. So unfortunately or fortunately, if any of the important structures or any concrete structures or any steel structure, if they face repair, then we should ensure that the repair work should be very good and durable. So in short, to summarize this whole thing, I can say that we need to keep them safe and usable for long period. say it may be some several decades as well, because doing a work again and again, suppose if you do a repair work again and again on the same and particular area, then it's not good actually, and it may create other problems. It may create other that load bearing capacity problems of that particular element or of that particular area of a structure. So without much, that last line, without much maintenance and repair. So we have to ensure that the structures are much durable, and we have to consider the environmental conditions as well. And without maintenance, without much maintenance, if you go and do the same type of repair work again and again on the same place, it's not good. So these things we have to take care. So this repair work is very important. A lot of cases we will see later in the upcoming slides that structure may needs mandatory repair work, because you cannot find any concrete without crack. So wherever there is a concrete, it will experience a crack. It may be after 1 month, it may be after the elastic shortening, or it may be after several decades. So you cannot find a concrete structure without crack, or you cannot find an intact concrete structure for the throughout the lifespan of the structure. How much the good quality of work may be done, but it's not possible to get a concrete without crack. So it becomes very mandatory to repair the concrete structure after certain time or after certain decades. So we should ensure that the repair work is also good and durable. So these are the some major factors or points we have to always think before going to any repair work. So whenever you need that, whenever there is a need of any repair work, so these are the prime points you have to always keep in your mind before starting, or before thinking that what methodology you are going to adopt for that particular repair work. So the first point is determining the root cause of deterioration. This is the most prime point, I would say, that root cause of deterioration is very important. So if you don't know, if you don't even try to understand the root cause, without understanding the root cause, if you do some patching work or some repair work, then again in future the same thing will happen, and again you have to go in the same place and do the same work. So we should determine the root cause, and we should do some precautions. We should adopt some precautions to stop that root cause which is causing the deterioration of the concrete structure. So determining the root cause is very important in the case of repair work. So the next point is, will the repair materials be compatible with the substrate concrete? Because you see, when we used to do some repair work, we are going to put some new material. The new material here in the, if you can say, it may be concrete, it may be any type of material, even steel plate or whatever. So we have to be very sure that the materials that we are going to use for the repair methodology or in the repair methodology should be compatible with the substrate concrete. Concrete which is there already, the old concrete, what you can say, there should be a proper bond with the new material with the old substrate. So the old substrate may be any material in the construction site. So we should be very careful in the selecting of materials, because it has been seen that the selection of material, if it goes wrong, there may be a huge problem in the repair work, and the repair work may not that exist for a long time. Again, you have to go and do the same work. So the third point is, will it need frequent maintenance? So we have to see that if these types of maintenance, suppose if any a lot of repair work, you can say, I mean, I have also seen, if it is a structural crack in the repair work, if it is a structural crack is there, it may be in a beam or it may be in a slab. If there is a structural crack, then how much do you repair if you don't control the loading, or if you don't give any extra support to take the extra loading? Then even if you do a very good repair work also, the element or the structural element may suffer further crack or further distress. So you have to see that will it need a frequent maintenance or not. If it need a frequent maintenance, how to stop it? How to stop the frequent? Because frequent maintenance is not good at all. And in some of the important structures, or in some of the structures like as the dam structure, or some of the that underground structure based that at that in these types of particular the place, you may need some frequent maintenance. But for normal constructions or normal structures, if you say it's like building or bridge or whatever, in these types of structures, frequent maintenance is not a good thing, because you have to hold the working of the structures, you have to stop the working, the usability of the structure, and it's not good actually to do the things like frequent maintenance. So the work, the quality of work also may not good if you go for frequent maintenance, because you cannot stop the usability of a structure again and again after a regular interval of time. And if you do such also, then one tension will be there, to complete the work as early as possible and to get out from the site. These things actually it's not good. So we have to find that's why I told the prime point. We have to find the root cause of the distress, or the why these cracks are forming, or why that patches came in a concrete surface, or any type of deterioration, why it happens. Actually, you have to find the root cause behind it. So if you can able to determine the root cause, it may reduce the frequency of frequent maintenance. The last one is, will it ensure durability, cost effectiveness, and aesthetics? So the 3 points I have mentioned. So whenever you are going to do any repair work, you have to see that the repair methodology that you have adopted for that particular repair method, or for that particular repair work, will it be durable or not? Then you have to go for a deep study. So this is that's the thing. So in a light we'll see in the upcoming slides or upcoming discussions how to ensure the durability and all. We'll see that this thing. So it is very important to ensure that the durability of work is not only for repair work. If you talk about new construction also, it is very, very important to do a durable work. So when we, so now I want to tell you something regarding that word durability. Most of the civil engineering students and even civil engineers as well, I have seen, it's my own experience, when we used to speak about durability, people used to pronounce, or people used to say some test name. You can say RCPT, rapid chloride penetration test, half cell potential. So these types of test name people used to do. So when I ask anyone what is the durability of a structure, or what is the durability of concrete, if I especially use that word concrete, people used to say this test name. If you can say, if you ask anyone what is the workability of concrete, people will say slum cone test. Slum cone test is not the workability of concrete, and RCPT is not the durability of concrete. We are doing this test to determine the durability of the concrete, or as well as the workability of the concrete. So these are the tests performing for determining the durability as well as the workability, as I told slum cone test. So you should know what is durability. Durability is nothing but the mechanism or the process by which we can make a it may be a concrete structure or whatever. We can make a structure to persist for a long time against the environmental loadings and the structural loadings, or whatever the things. Whenever you're exposing a structure to the open environment, it should last for a long time. It should last according to the desired design period. So if it serves this purpose, then we can say that a structure is durable. So durable is that, kindly go through the literal meaning of durable. Okay, so don't always that come up with a test. Okay, that RCPT is one test, only one test for determining durability. There are n number of tests. You can say hundreds of tests are there to determine the durability, as well as hundreds of tests are there to determine the workability of concrete. So this is very important thing I have noticed in the future generations. Within the future generations, those who are studying now in various engineering colleges, and also in some of the engineers as well, I have seen in most of the site engineers. Honestly, I'm speaking, I heard all those things from them. But you should know that learning is a continuous process. You should always remember that learning is a continuous process. So you should not hesitate in learning. So now the second point is cost effectiveness. I'm going fast because the number of slides are somewhat more, and I am trying to make the video somewhat compact so that you may not feel bored. Okay. So the cost effectiveness is also important thing. So when you are going to do some repair work, especially when you are going to select some material, we have to see the budget of the repair work. We have to see that is it cost effective or not, and based on your budget you have to select all the repair methodologies, including from the that selection of materials to the end of the project. And the aesthetics, when you are going to say the repair work, so we are going to demolish some, we are going to cut some part from the old structure, we are going to do some patches, or we are going to do some extra adding of some materials, or some gluing of some materials, you can also say. So we should take care of the aesthetics also of the structure. So simply we cannot take we cannot adopt any method in the repair methodology. The aesthetics or the cosmetic view of the structure is also very, very important, if you say for the building especially. So any building structure or multi-story structures, if you do some repair work inside the room or inside the structure, the aesthetics and cosmetic view of structure is also very, very important. So you have to take care of all those things. So before selecting any repair methodology, we have to go through all those things in very deep. I have given these 4 points. These are the prime, but there are n number of points we have to consider based on the type of work, based on the situation of the repair work we have to do, the extent of how much repair work we have to do, what is the extent of deterioration, how much the structure got damaged, and how much we have to do the work. Each and every step we have to study in detail before selecting any methodology. Simply we cannot say that do this work and come back. No, it won't serve the purpose. So again you have to go there and do the same thing. So we have to be very careful, and we should ensure it very carefully that the root cause of the work has been determined or not. We have to determine the root cause of the structure if we need to minimize the frequency of maintenance. So now you can see here I have got this data, very informative. So I also shared with you people. Most often the maintenance and the repair are more complicated than a new construction. So whenever you see that whenever you are going to do some new constructions, you will find open ground and you can adopt any methodology, and there won't be any constraints. There won't be any constraints around you, so you can freely do a work. But in the case of repair work, it's very challenging, and it's very hectic also to do the repair work, because you will have a lot of constraints. And most important thing is that you are halting the usability of the structure. You are stopping the structure to be used by the public people. So you have to finish the work as early as possible, and you have to come out from the site as early as possible. So it's very, very challenging and hectic to perform a repair work. And if you adopt a wrong process, so it's a very bad thing. Sorry, it's a very bad thing. So again, you have to go and face these types of challenges, and people will not also encourage you if you do like this. So repair work is very challenging and hectic. So you can see the picture over there. The person is telling that you could build cool and new stuff too. It's only you hadn't dug a big deep hole. So at the time of new construction, you have to dug big holes and all for foundation works and all. But still it is somewhat comfortable because you don't have any constraints. But in the case of repair work, you can see that person is there in the ground field, that brown field on the right side, you can see that he's telling come down and say it again. So repair work is really very challenging thing. So we have to think about very nicely or very deeply. We have to think which types of repair work we have to adopt, or which types of repair methodology we have to adopt. So this is very important. So here I want to give you a particular data as well as some chart. You can see the chart. So I have seen in a lot of the cases that the construction, in any construction project, when it requires any repair, I have seen a lot of construction project before inauguration itself it needs repair work. So this is not actually good. This is the poor, very poor workmanship. So even a structure, I hope that you might have heard this thing also, structure before inauguration. So this is very bad thing. Being a civil engineer, you should not do like this. So there are multiple stakeholders. Stakeholders are there for a particular construction project, and it's very wise if one person takes the responsibility to communicate with all the stakeholders. Because what happens if a proper communication is not there, or if a proper transformation of the data or the things is not there, then there may be that blame game may happen. The blame game means the designer will blame that repair work, those who did the repair work, or the person who is doing the repair work. They will tell that the designer, it's a fault of design fault, so it came like this, so it happened like this. So we should not do like this. So one person should take care of all the things. He or that particular group of that of any company or construction project should take care of maintain a proper communication with all the stakeholders that you are watching, that you are viewing in the screen. There are n number of stakeholders: government authority, consultant, special consultant is very, very important in the case of repair work. So getting the root cause, you may need to know about the root cause, you may need to consult some special consultant, then material supplier, that contractor, subcontractor, and the main contractors. So these are all the they are all the stakeholders, and one person or one authority of any company or any construction project should take the responsibility to maintain a proper communication with all the stakeholders, all the department also, you can say, to maintain a smooth construction work or repair work. So here you can see that the point, equipping the engineers to dictate the technical requirements. Equipping, so equipping, it means a lot. Okay, so the proper communications, so and the proper equipping is mandatory to achieve a smooth construction project or any repair project. So this chart shows for construction project. The same thing is there for repair project as well. Okay. So this is the code book ACI 562 code that American Concrete Institute have that developed this book that you can say it as a document as well, code book, which helps us to understand the various repair process, and the objectives are there. You can see the main objective of this that document is to establish a good practice and evaluation and design materials. So here also they have mentioned that for evaluation. So evaluating the problem is very, very important, and based on this evaluation, based on this result, you have to go for design. Design here means the repair methodology and material selections and other things. To raise the level of performance of the repair and production system, to establish clear responsibilities of all authorities or participants. So who are all the participants, and what are all the responsibilities of them? So it's also mentioned in this document. So you can download this, or you can refer this document for knowing about the step-by-step process of repair and rehabilitation work. So this is the book also you can refer, that Peter H. Emmons. This book is a very, very informative book, and you can find a lot of practical and analysis also, but there are a lot of case studies and how to determine a lot of that root cause. So this book is very, very informative, and I have used the materials or some of the data from this book also to prepare this presentation. You can also take this book as a handbook or as a guide for the repair and maintenance work of concrete structure. So you can find the details of the thing in this book. You can okay. So here it comes, why the repair work is important, and the various data of the repair work. So up to in 2014, it has been seen that in India, the cost of repair work is about 4 lakh crores rupees per year. So just I don't have a pointer. You can see the first bullet, the amount, how much it is, 4 lakh crores per year we are expending for doing repair work. So this is a very, very, very huge amount of work, money we are we will say that we are wasting in repair work because of poor workmanship and the less durability. And you can see here that 3 to 4% of our GDP is on this repair work. It's if you see, the number is quite high, but if you can go and search in Google, or you can get the data from different experts also. So you can get the same data there also. The minimum that 3 to 4% of the GDP is we are expanding this much of amount for our repair work. And you can see that 50% of the construction budgets has been we are utilizing the 50% of construction budget as repair work. So it's a very bad thing for our country. And 50% of the structure hits a repair in about 10 years. It has a data, it's a survey that has been conducted that 50% of the structure. So this data may be less, this amount may be less because it's not possible to go and detect all the structures across the country or across the nation. So these data are, according to me, this data is quite low. If you say this data is quite low, we are not giving enough importance of all those things. If you also see a crack in a building, you won't give any enough, not even that any. You don't go for any visual inspection also for these types of things, but it's quite dangerous. If you see in the upcoming slides, we'll discuss how much dangerous the deterioration process may be in a concrete structure. So that 50% of the construction budget we are utilizing for that repair work, and 50% of the structures also hits repair in within 10 years. So I hope so. Not a single building in across the globe has been designed for 10 years. Some except the temporary structures. Any permanent structure is not designed for 10 years. Minimums for some several decades they have been designed, or their expectation from the structure is of several decades. But it has been seen that 50% of those structures are that are requiring maintenance. They need maintenance after 10 years. So this is, we have to see that why it's happening, to find out the root cause, and we have to that avoid all those poor practice at the time of construction itself. So the last 2 points that you can see here, that 30% of the steel is used for repair work. So in the whole manufacturing of steel, it has been seen that 30% of the steel is used for repair work and 40% of cement is used for repair work. So these two data, 30% and 40%, are quite alarming. So if you see these two data are quite alarming, and here also you can see the data is very the amount or the number is quite high. You can also verify with concrete industry or cement industry or repair that steel industry. You can also find the same data over there. So that 30 to 40%, 30% of steel is using only for repair work, and 40% of steel we are using, 40% of cement, sorry, we are using for repair work. So this is not actually good. And even it has been seen that if we go for a repair work also, it doesn't last for a long time, as I told a couple of slides earlier. So the durability matters a lot of these types of works, even for a new construction and for the repair work as well. So you can see that the amount that we are expending for the repair work. So if we perform good repair work or a durable repair methodology, or even a good construction process, we can reduce this amount and we can utilize this amount for the development of new infrastructure. So this is also very, very important, that upcoming civil engineers and already those who are working inside, they should take care of all those things. And even the CEOs of different construction companies, they should take care of all those things, that how to save money for the development of our society. Because utilizing that much of huge amount in repair work is not good, and it won't help us to develop the society by constructing new infrastructures. So it's quite important. So now we'll see some different reasons of structural distress. Here it comes that the three main reasons are that corrosion of embedded bars. So we are using reinforcing steel bars inside the concrete, which gets corroded after some particular time. And we'll see that this is one reason for that distress. And the degradation of concrete system itself is also one more reason for the concrete structure to get deteriorate, and the failing of repair works. So these three prime points I have mentioned here, there are n number of reasons. So these prime points we will discuss. So corrosion of the embedded bars. So before doing this, we should know about the corrosion map of India. If you see that our map, our country map, the whole that southern part, this part you can see the whole peninsula is a big coastal line is there. So a long coast of 7,000 kilometers, the coastal line of 7,000 kilometers. So this area will always will be exposed to huge amount of chlorine, and this coastal area is more prominent for corrosion. You can see the map here, and even in the cases where it is not the it is the mid part of the country, if you can say, if it is even not a coastal area, but if the humidity is more than 60% to 70%, then we may also have a carbonation induced corrosion. So if you see the corrosion in the structure, the main reason of corrosion is that chloride based corrosion and carbonation based corrosion, and with the presence of moisture and oxygen. So if you see the our country the map of our India, you can understand. I have that the markings has been given over there, so you can see that how much that the coastal area may be prone to the corrosion. So based on this, we have to take different that adaptive measures at the time of construction and the time of doing repair work as well. So why we use steel in concrete? This is a very common question. If any engineer or any civil student, after those who complete their degree, if they want to go for any construction company, most of the construction companies, they're asking this question: why you are using that steel in a concrete structure? Most of the people in the first attempt, they will answer that steel is abundantly available. So even in a very good high project, with high budget also, there also we won't use any other high cost metal or high cost material also, but we are using steel only. There is a particular reason. There are two reasons primarily why we are using steel in concrete. The first reason is the coefficient of thermal expansion of both concrete and steel is same. So you all know that concrete, the reaction in concrete is a hydration reaction which evolves heat. So when it evolves heat, so in a mass concreting system, the reinforcing in the core of concrete may expand due to this heat. So the way the steel and concrete both expands and comes back to its original position after that, when the that heat dissipates from the structure, should be same. The rate of expansion should be same. So the steel is having the same coefficient of thermal expansion with respect to concrete. So that's why this is the main reason we're using steel. And one more reason is that when we dip a steel, or when we're going to give the cast concrete on any reinforcing system, then a passive film is automatically generated around the steel bar. So passive film, in the diagram you can see here, the green color area around the bar. So this green color area indicates the passive film that generates when the concrete is poured into a reinforcing system. So you can see the point. Steel doesn't corrode due to high pH of the concrete core solution. So when we pour concrete in a system, then immediately the pH level around the steel bar, increases, and this zone is known as passive zone of bar, which helps the bar or the steel bar to get protect from the corrosion. So corrosion means there should be some acidic environment, so which will induce corrosion. So if a steel bar wants to get corroded, we have to break the passive film, or the passive film should get break, so that the deleterious materials can reach to the steel. So so how it happens, we'll see these things in the next slide. So the most of the case in the depassivation, or the depassivation here means breaking that film. The depassivation or the corrosion may happen due to the presence of chlorides and carbon dioxide, with the presence of humidity or that moisture and oxygen. This is very, very important. Without the presence of oxygen and moisture, the chloride or the carbon dioxide may not take parts in the chemical reaction to involve corrosion, to start corrosion. So here you can see in the left picture, there's a bridge which is in sea. It's around in a this structure is in a marine environment, so it may suffer from lot of chloride attack. And here you can see this is that flyover in that metro city, where you can see the concentration of CO2 is the local concentration, because lot of traffic jams over there, lot of traffics are there. So the local concentration of the carbon dioxide is quite high in this region. Even it is sure that the carbon dioxide will dissipate into the atmosphere, but still in that the local concentration, if you see, local concentration of the carbon dioxide is quite high, and you can see here the presence of oxygen as well as moisture is also there. So it will, here this structure may, or it suffered from that carbonation induced corrosion. You can see the stains over there. So these are all the carbonation based corrosion. So we have to know the reason behind the corrosion or in any of the distress method. So in general, the corrosion in a concrete structure is governed by chloride attack and carbonation attack. So here we comes how the corrosion happens. Most of us, we know the process. So this is like a recapping of all those things. So whenever we need whenever the corrosion happens, there is an electrolytic cell. So the essential parts of a corrosion cell I am showing here. There is electrolyte, and the electrolyte here it may be a water system, it may be a water body, or it may be a concrete system. And the metal here in our discussion, it's steel. So automatically there is a generation of two potential in between the same metal, and these two potential acts as one as anode and another as cathode. So what happens, from the cathode the current flows to the anodes, which that again the electronic conduction, the ionic conduction takes place through the electrolyte. So there should be presence of ionic conductor, and there should be a presence of electronic conductor, and there should be a presence of two electrode for completing the whole corrosion cell. So once we can avoid one of these from the system, we can avoid corrosion. But in practice, it won't happen. It's not possible as well also to avoid any of these things. So you should have a concrete system. You should have you will have that metal also for reinforcing things, reinforcing the concrete system. So it's not possible to remove anything from the concrete structure. But we have to see how to control these things. Okay. So now these are the reactions. It happens in the anode part and the cathode part. So in anode, the iron that divides into two parts, Fe2 plus and 2 electrons, and these electrons are transferring. These electrons are transferring from the anode. These electrons are transferring from the anode to the cathodic surface to form the hydroxide over there, which is known as the rust. It will form here. Okay, so from the cathode, what happens? From in cathode, it will go and react with that oxygen and that moisture present over there. In the cathode here, if you consider that it's an electrolyte or concrete system, you will find that oxygen and moisture over there. So the electron will go from this anode and will react with the oxygen and that moisture or water to form hydroxide ions. So these hydroxide ions will again react with the Fe2 plus ions to form that ferric hydroxide or that the rust. So this is the thing. So this is the picture you can see here. This part actually, which is just above the water surface, this is actually that bridge pier. So if you go down to the water, you won't find that much of corrosion, because there is not available oxygen over there. The oxygen availability is less. And if you go above this damaged part, if you go towards, if you go up to the pier, you won't find enough corrosion, because the presence of moisture is somewhat less over there. So in this region, the wet and dry region, you can see that much corrosion happens due to the presence of both moisture and oxygen, and also the waves that are coming continuously hitting the pier also that increases the rate of chloride invasions inside the concrete. So it is the pressure, the pressure that is given by the wave of the water, it's inducing the chloride ions to go inside the pier to make the system corrode. So this is the mechanism again. In short or in detail, we have that I want to show you what happens in a corrosion cell in the same bar. That actually corrosion is a process where you can get that both reduction of volume and the increment of volume. So some people will say that when corrosion happens, the volume increase, and some people will say that when corrosion happens, the volume decrease. If you see from the materialistic properties of the metal, you can say that the volume decrease because the material is going to deteriorate due to the corrosion process. But if you see in overall in the whole system of concrete, we can say that due to the corrosion, the volume expands or volume increases. So here also the same thing you can see in the anodic part. The iron is divided into two parts, two ions. One is Fe2 plus and 2 electrons. These 2 electrons go in the cathodic zone through the electronic conduction and reacts with enough moisture and oxygen present over there to form hydroxide ion. So this hydroxide ion will again react with the Fe2 plus to form the rust. So now here you can say that in any of the electrolytic cell, we need a separate anode and we need a separate cathode. But how it happens in a single metal? This is a big question. So you can, it is possible actually. It's possible, and as it is possible, the corrosion is happening. So anode and cathode can coexist on the same piece of metal. So why it may happen like this? How this process can happen on the same piece of metal? So these are the some main things. If we study, so these are again a detail. So I want to explain something little about it. So if you see the due to the non-uniformity of the metal, due to the non-uniformity of the electron, so when we are going to take a bar or any metal, it's not uniform throughout this section. If you go for a microstructure study or if you go in the microstructure level, if you see the metal surface, you can understand that there is a huge non-uniformity in the surface itself, it happens in the time of manufacturing process as well. Same in the electrolyte. When you come for a concrete, the concrete structure is how much we say it's homogeneous, but in practice it's not possible to get a homogeneous mixture of concrete because we are not doing the whole casting of a building in one day. So we are doing the casting of the whole building or the whole structure in multiple numbers of time and in multiple steps we are used to do. So the mixture is not at all homogeneous. Even in the same mixture also, you cannot achieve a homogeneity across the concrete structure. What we are using here is the electrolyte. So here in the concrete system, the concrete is the electrolyte. So it's not possible to get homogeneous. So due to this non-uniformity, there may be some potential difference, or due to the non-uniformity of the microstructure properties of the metal that we are going to use as the bar, that steel bar. Due to the change over there may be some the difference in the potential, which may act as one as anode and one as cathode, and also the non-uniformity of the physical conditions of the concrete structure. So these are all the some reasons why that both anode and cathode coexist in a same particular metal. So if you want to understand this is just a different story. So you can, it's a different study of all these things. In detail we have to discuss. Okay. So now here it's a picture from Colosseum, Croatia. So here we can see that how much dangerous the corrosion may be. So whenever corrosion happens, it expands, as you can see there in this reaction a couple of slides earlier. So the accumulation of the rust may expand the volume of the bar, which will exert pressure, outward pressure, and will make the concrete to get to form crack. So it's actually a rock, natural rock, and this is a steel bar which is drilled inside. So when it suffered from corrosion, you can see that how much expansion it happens and how much crack it happens. So if it can crack a rock, it can easily crack concrete, which is a human-made rock. So it's quite possible to get a crack due to this corrosion. So this is the reason why concrete structure gets corroded, that spalling happens or crack happens when we used to get corrosion. So this is one example. You can see that how the crack initiates and how the delamination happens and how the spalling also it happens. So the process of the thing is we should stop the corrosion in the initial stage itself for not making the structure like this what we are viewing in the screen. So we have to stop the corrosion process as early as possible. We'll see some of the methods in this lecture, how to stop corrosion process and all. So the Professor David Trejo has given one line that influence the next generation civil engineers to design not only for strength but also for durability with minimum maintenance. So this also I got very much informative. So I took these things for the presentation. And if you see, he mentioned very clearly that not only for strength. So now also I want to say to these students, civil engineering students or diploma students or even the civil engineers as well. Whenever we used to discuss anything about the concrete, people see that how much MPa, how much is the strength, what do you have mixed for getting this strength. So strength is not the ultimate thing. The durability also matters that much important for the concrete structure. So durability, you have to, it's my that request to all of the manufacturing companies, those who are manufacturing concrete and those who are doing construction project works, kindly please ensure one durability property with the strength property. Suppose MXDY, I don't have anything to write and show you. MX or M20 means 20 is the strength. M20, and with this M20 give some durability properties. So if you do such types of practice, it will be quite good for getting a quality full concrete which is durable for a long time. So kindly ensure that your concrete is durable or not. If you have a huge, if you can miss a lot of admixtures nowadays available, a lot of process also nowadays available. People are replacing cement by different types of materials to improving the strength of the concrete. But improving the strength is not the main thing. Main thing is that is your concrete system is durable or not? Will it last for a long time? This is the question. So it has been seen, I have showed you the data, within 10 years the concrete structures are getting distressed. So you have to take care of all those things. So now we'll see some different types of bars. So we know the different types of bars. So CTD, plain and ribbed bars are there, which are hot rolled. CTDs are there, cold twisted deformed bars. So nowadays we are not using cold twisted deformed bars because the manufacturing process that we are adopting for manufacturing the cold twisted deformed bars is we are twisting the bars. So when we are twisting this bar, there is a residual stress which remains over the surface of the bar, which induces corrosion, which helps the system to get corroded earlier as compared to the other things. So most of the cases nowadays we are using TMT bars, that are thermomechanically treated bars, or if you want to say this term technically, more technically, then we have to tell it as a quenched and self-tempered bars, as QST bars, steel bars. So the mechanism here we are providing here, we are giving a layer of thermomechanically treated layer we are giving across the cross section of the bar, and to ensure the quality of this bar, I am requesting everyone to go for PM ring test before utilizing this bar in a construction. So the next one is a corrosion resistant bar is also nowadays available. Stainless steel bar is also available. But stainless steel bar is quite expensive. So in most of the construction projects, we are not involving stainless steel bars. And now prestressing strands. So in pre-stressed concrete structure, it's a different scenario we used to see. It's not possible to explain here in detail now. So the process, if a normal construction bar, bar which we used to see in normal construction, if it deteriorates, then you can easily see the cracks that are coming, or the stains, the rusting stains that are coming out to the concrete surface. But in the case of pre-stressing strands, it's actually it says hidden corrosion happens. because I don't have it to show you. There are n number of wears will be there in a strain. So when the strands, when the wears will start corrosion, will induce corrosion, will induce on them, then the first that corrosion products will accumulate on the spaces in between the strands. Once the accumulation gets over on these particular spaces, then only it will come up to the concrete surface. So for getting the that alarm of corrosion which happens in prestressing strands is quite dangerous, because you can get the alarm after a huge devastating effect also. And in the most of the cases, it has been seen that in prestressing steel strands, local corrosion happens more than the normal corrosion. Local corrosion means a particular region, a particular point, pit hole. It will have a pit hole and it will damage the strands. And if it damages these strands in one particular point, it will not be able to take the whole load. It will not be able to take the enough bond or enough and that anchoring that has been given or that has been designed to for that particular assembly. Next part is galvanized steel. So galvanized steel also you can see. So now I will say one more thing after completing this. So the galvanized steel also nowadays we are using for that construction process. Then fusion bonded epoxy coated steel bars. So in these bars we are giving a epoxy coating with some process. This is a different story. So this is also one type of bar. You can see nowadays also using in construction projects and all. And cement polymer composite coated by steel bars, and the last one is FRP bars, fiber reinforced bars. So when we used to discuss about the last two, 8 and 9, number 8 and number 9. So we should be very careful that the fusion bonded epoxy coated bars or cement polymer composite coated bars, we should not cut the bars or we should not bend the bars after the bonding has been done or after the coating has been done. If you do a bending over there, so in the bending there may be a delamination of the coating, so which will helps the deleterious materials to get effect in the main steel bar. So the coating in most of the cases it has been seen like this, and the ultraviolet rays also plays a vital role in this factor. The coating may get affected due to the ultraviolet radiation of the sun also. So the cutting and the bending of bars should be done before the coating system of the thing. So it's like somewhat in the factory itself we has to have some common size of stirrups, common size of bending angles, common size of bars. We should not again redo any work by using these bars in the construction site. If we do, then the purpose of giving this coating will not serve. Okay, so it will not serve the exact purpose. So now we'll see some of the deterioration effect in the concrete system. The first one is, I'm going fast because I have to complete. So it's a huge video, long course module. So we have to, I'm going fast. So, okay. So the sulphate attack, I'm going to share all those things with you, that materials. You can have all those materials at the end of the webinar, and you can refer these things also later. So the first problem that we used to see in concrete system is sulphate attack. So when the sulphate attack happens, so before going to the deterioration system, I want to say something important about the concrete system. So here you can see two pictures, one in the left and one in the right. Here the cover concrete we used to call this cover concrete as covercrete, and the concrete which is there inside the reinforcing system we used to call it as hardcrete. So the picture in the top left side, you can see that the peripheral region of the concrete system, it is this texture shows that the concrete quality is not good and the concrete is porous. So if the cover concrete or if the covercrete is porous in nature, then it may create a problem and it may allow the deleterious agents to get inside, which may corrode the system, the reinforcing system, and it may also create different types of chemical reaction in the concrete system. So if we need a good quality of concrete, we has to have a good quality covercrete and a good quality hardcrete. So this is the message from this slide. The next one is how to achieve these things. So the proper usage of mineral admixtures, proper usage of chemical admixtures, proper use of the proper process of particle packing, and the proper adequate curing and proper curing will help us to get a desired workability, strength, and durability. So durability and strength and workability, both these three properties of concrete is fully based on the different types of process that we are adopting at the time of mixing concrete. So particle packing is, if we have to reduce the density of the concrete, we have to increase the density of the concrete by doing the particle packing. So this is a different story. We are also that it's a long time research process that we are conducting in the civil department of an Institute of High Technology. So the process is going on since last 1 year. So it's a continuous process, it's an iteration process, so try and error process, so that how to get the particle packing. So if it is possible, I will discuss regarding this particle packing in one more video. You can see. So again, I am emphasizing one thing more and more: adequate curing. Adequate curing is a very, very important thing. So if you have a very good material, if you have a very good mixing properties, if you have a very good placing of concrete as well, but if the curing is not good, you won't get the desired strength of the concrete, and within a very short time the concrete may start falling. I'm not going detail in that. I hope so you all know about the importance of curing. And one more point here to notice is we have to use the cement as a binder, not as a filler. That blue color, you can see the mouse pointing. We have to use the cement as a binder, not for a filler. Why I am saying this thing? Because most of the people used to say that if you need a high strength concrete, use more cement. If the cement is more, the strength will be more. No, it is not always the correct thing to do. Because why I am telling this thing? Because probably cement is the most reactant material in the whole concrete system. So if you give more cement, it will react more with the different types of agents that are present in the concrete system, which may create a problem in the metrological behavior of the, or mineralogical or chemical behavior of the concrete. So using more cement is not always a good idea. So if you want to get a durable concrete, we have to ensure that in the mix design itself, there should be minimal use of cement content, and cement should not use as a filler. Nowadays we have different types of mineral admixtures. We'll see these things in the couple of slides later. So to increase the density or to use this as a filler, but more the reactant materials you use in the concrete system, more that distress may happen due to chemical reactions. So usage of more cement is not always a good idea. Don't be in the myth that if more cement, more strength will come. If more admixture if you give, then more strength will come. It has been seen that if you involve much more chemical as materials in a concrete system, the system doesn't long for a long time. If it has not addressed properly, you have to address all those things very properly in a very good way also to ensure the durability of structure. Okay. So now in the sulphate attack, it depends on two types, that how the sulphate or the things are, the sulphate materials are coming in contact with the concrete. So it may be internal and external. If I'm going very light on this, the internal source of sulphate and the external source of sulphate. So now you can see here the picture from left to right. So the leftmost picture is, you can see some needle-like structure. It's nothing like a tringite. When a cement or concrete used to react with sulfur, then these types of ettringite or needle-like crystals used to form, and the volume of these needles is quite more than the volume of the reactants. So which used to occupy the space or occupy the pores, and if it happens in a large extent, it exerts a pressure, which you can see in the next picture, middle picture. You can see that the dark color round shape is aggregate, and these are the paste, Now you can see, 1 minute. Sorry for some technical issue happened. So you can see on the next the middle picture, you can see that due to the that these are the dark gray color things are aggregate, and these are the cement. So in the cement and the concrete or cement aggregate interface, you can see the cracks. I don't have any pointer. You can see here the formation of cracks over there. So the right picture, you can see that the type of cracks that it happens when the sulfate is going to attack the concrete system. So you can see from microstructure level to the macrostructure level how the cracks may happen due to the sulfate attack. These are also some of the examples that I have collected from the materials of NPTEL. These pictures, I found that it's very, very good pictures to show you that how dangerous or that what the effect or what the consequence may happen at the time of sulfate attack or due to sulfate attack. How to prevent sulfate attack is this is also one more thing, some detail we'll cover all those things in the that upcoming next video if it is possible, or next webinar. So how to prevent sulfate attack? We have to ensure that the cooling temperature should be low, and it should be below 70 degrees centigrade, and the concrete with low permeability concrete mixed with the cement which have low C3A content. Sorry, the C3 should be suffix here, so it's a mistake. So okay, C3A content, the content of C3A in the cement should be less, because the C3A content of the cement reacts with the sulfate to form these attringite-like structures, and if the moisture availability is more, then also the structure may suffer from that sulfate attack. Okay. So now we'll see that the alkali aggregate reactions. In alkali aggregate reactions, sometimes it is also known as alkali silica reaction. So the silica present in the aggregate which reacts with the alkali of the cement or concrete system to form a swellable gel. So the volume of the gel will create a pressure and cracks may come out. So you can see one picture over there. Sorry, one picture in the left side. These types of cracks may happen due to alkali aggregate reaction, and the right picture you can see the microstructure level. So these are the aggregate here. The gray, sorry, the gray color is the aggregate, and the violet color thing is the formation of gel. So that is a gel in between this in between the two aggregates. So this gel will expand, or it will create a pressure to the microstructure. In the microstructure level, it will give a pressure towards the aggregates. So the aggregates will tends to move outwards, creating this crack. So now that biofouling is the growth of unwanted growth of plant microorganisms, algae, and on wet concrete surface is known as the biofouling. So biofouling is the process by which the microorganisms, you can see in a lot of the cases, you can see that there may be some growth of herbs in concrete structures and all. So what happens actually, these things when get they start their metabolism, the microorganisms or the herbs or algae or plants, they start their metabolism in a concrete surface. And if you talk about herbs or some plants, the root of these plants or herbs used to go through the concrete, which will create a crack. So even in the case of microorganisms, if you talk about microorganisms, the excretions that they do, the organic acids of these microorganisms may change the chemical or that microstructural states of the concrete system. Here you can see the next slide. Then some examples of biofouling, how dangerous it can be. You can see here the picture in the bottom picture, that yellow color, that pier, that you can see how dangerous the biofouling may be. So it's we should not allow these types of things to happen. So regular monitoring. In the last part 1 lecture also I have told, after the construction process gets over, we should monitor the structure regularly to avoid such types of things. So here also you can see some attack of fungi and bacteria, algae, and all those things, how it can in macrostructure level also, how it change the position of the aggregates inside the concrete system, and also involves chemically in the aggregate in the concrete system. So acid attack, you can see in the household and due to certain industrial waste, and the manhole structures. If you see the pictures down, manhole structures and inner surface of sewer pipelines, there you can find a lot of organic acids, and even there may be different types of reaction which involves to produce a lot of that sulfuric acid and nitric acid. So this is also a different story. It's not possible to go in detail. Cooling towers, chimneys. So these are some of the important structures in food industry also. In food industry and a lot of types of industry which works with chemical, different types of salt manufacturing industries as well. So salt manufacturing industries are prone to both for that acid attack as well as for the chloride induced attack. So we should take care of all those things, and we should think how we can make the concrete surface not to get distressed due to these types of attacks. Fire attack, you can see the fire attack is a step-by-step process. The deterioration that happens in the fire attack is a step-by-step process. First, when the fire will touch the surface will start removing losing the moisture of the surface of the concrete surface, which can create which will decrease the density, as well as it will create a problem also in the structure. And slowly it will happen, and slowly it will go inside the concrete system step-by-step process. And if you don't address the fire, if you don't control the system or mechanism, it may create a huge problem. You can see in the picture, the right bottom picture, you can see how much the structure got affected due to the fire attack. So the next one is freeze and thaw attack. In freeze and thaw attack, I found some of the materials very informative to understand. So I'm going very lightly in that. Freeze and thaw attack is called when we used to do some construction in some polar region, or where the temperature is somewhat less. You can see the moisture or the water gets accumulated in the pores of the concrete, which also in time forms or which turns into ice or that snow. So you all know that when water gets solidified into ice, there is an approximate 9% increase in the volume. So when these, if the pores which are there in the concrete system, if the pores are not that suitable to accumulate that particular volume, then it will expand. Then it will give a pressure towards the pores, and the things may turn into a lot of it results in formation of cracks. You can see the picture in the middle, how that white color, these are the formation of ice, and how the cracks may happen in microstructure estates. So how we can reduce these types of things? We can add some air entering admixtures. So it will create some extra bubble type of structures, or it will give some space over the concrete for such accumulation when happens. So by using some air that entering admixtures, also we can prevent these types of freeze and thaw attacks. So very briefly, I went through all the different types of that factors which governing the deterioration of the concrete system. Now, failing of repair works, you can see that this is an example. So actually the pier, the column, or you can see that the pillar has been has suffered from corrosion, and the concrete came out from that particular part. So without addressing the main reason of the distress, simply they have did some patchwork. You can see very clearly here they did some patchwork over there. You can see that my mouse pointing that patchwork, new concrete system, and this is the old concrete system, and this is new concrete system. So without addressing with, because if you don't stop the corrosion, then giving a patching work will not stop the corrosion. Only once the corrosion starts, it will continue in the bar. We have to stop the corrosion. We have to stop for entering the deleterious agents into the concrete system or into the concrete to stop the corrosion. So again, the corrosion was still was continuing, and you can see again the cracks came out. So the failing of repair work also matters in the deterioration of the concrete structure or concrete system. So now we will see some of the repair and strengthening techniques. For the main important thing, if you go across the anywhere, if you see some old structure, you will see that a lot of the structures are suffering from corrosions, and mostly the tropical region. If we talk about the region Tamil Nadu, Kerala, and then Mumbai, these sides, that whole coastal zone, you can see the main reason of the deterioration is corrosion of the bars. So now I want to, before going into that particular method, I want to explain very briefly about different mechanisms that you can adopt for maintain or for reducing the corrosion, or to prevent or protect the corrosion in a reinforcing bar. You can see the picture here. This is a bar. This is a bar that has been embedded in the concrete. So what are the different factors or different methods we can adopt? The first method is the alkaline slurry protection. In this method, we used to give some coating of alkali, which will increase the pH of the bar around the bar, or which will increase the pH of the environment around the bar, so it will reduce the corrosion. And the middle portion, the red color arrow, you can see that we can apply some zinc coating to the bar surface, which will sacrifice and which will get corrode and will prevent the steel to get corrode. And the second part is we are doing something that we are fixing some zinc plate over the concrete surface, and we should make very ensure that the zinc metal should get that very good connection with the bar. You can see the second point, this part. Again, I don't have any pointer, sorry. I can show you. Wait. So here you can see. So this part you can see that the zinc plate has been given over there, and this is connected to the bar. This is connected to the bar. So this connection is very important. If the connection is not good, the current flow will not be good, and the purpose of adopting such technologies will not serve. The next one is an anode connected to the bar. We are going to introduce a anodic system. So anode here means, again, if you go back to multiple slides earlier, we have seen that the cathodic and anodic positions of all those corrosion cell. So here in this case, we are going to provide or introduce some anode inside the concrete system. In either it may be a sacrificial anode or it may be an impressed current method, so to protect the steel bar from construction. and epoxy coated also. We used to give some epoxy coat to protect the steel bar from corrosion. So now the next slide we'll study about the sacrificial anodic method. That sacrificial anodic method is very I found it quite important. So and it's quite easy also to adopt. So sacrificial anodic method, if it is possible, the principle that we used to follow in the impressed current method and sacrificial anode method is quite similar, but in the case of impressed current method, we have to give a current system. We have to pass current through the circuit. But in the case of sacrificial anode system, there is no need to give any extra current or a flow of current. So automatically, the system will work. Or once the anode, you install the anode into the system, the whole system will work automatically. So in brief, I will discuss about the method, what type of method it is. So the next slide we will see. So this is the see, you can see here that the first three pictures in the top, first three pictures. Okay, the first three pictures you can see that they're mixing some alkali slurry, and they're mixing in some proper ratio will be there for mixing. And if you in the product, you can see the proper mixing process, and you can apply it on the bar, on the reinforcing bar by using some paint brush or something. The one thing we should ensure that there should be a proper, if you paint something, we should ensure of this thing, that there should be a proper bonding of the new concrete system that you are going to give in that particular, that you are going to provide in that particular region. The bonding should be very good. As the first very couple of slides, very early itself I told that the bonding system matters a lot in the case of repair work with the substrate system. So that anodic, sacrificial anode cathodic protection, SACP, or in some of the cases it is called as a CP protection method also. In this case, what happens, step by step I will tell you very briefly, that we are going to introduce a artificial anode in the concrete system. In the corrosion cell, we have seen that the anodic part of the metal is getting deteriorated. The degradation of the system happens from the anodic part. Now in this case, what we used to do, we used to introduce a artificial anode inside the bar, so that the bar should not damage, or the bar may not get damaged. Instead of that, we are going to artificially damage that anode system, which is implemented into the concrete system. So this anode, that CP in that anode, the galvanic anode system consists of a sacrificial zinc core. You can see the zinc core over there. You can see the pointer. That sacrificial zinc core is there, which is again die-casted with tie wires. The tie wires we are using here, you can see we are using these tie wires to fix with the bar, and one encapsulating mortar. An encapsulating mortar will be there, which is known as active cementitious matrix, and we should be very unsure of that this thing also, that the pH of this that encapsulating mortar should be around 13. The pH should be 13 because we have to make the zinc corrode. If the zinc doesn't corrode, the system will not work. So for making a zinc corrode, we have to provide that ambience of having high pH. With the pH of this encapsulating mortar should be about 12 to 13. So this is the some example how that anode used to get installed in a concrete system to reduce the corrosion. You can see. Now one more thing I want to say: the surface area of the zinc depends upon the demand of current and depends upon the surface area of the steel that we are going to protect by using this system. So if the surface area of steel is more, then we need a more number of anodes, or it is not possible to install a lot of anodes. Instead of that, we can make some we can make such types of anode which will have a very good area or very more area of the zinc. So there are n number of shapes which are available in market that we can use for using this as a anode CP method or a cathodic protection method. Now, one more thing I want to mention here is, before installing these types of anode, we have to make sure that the connection has been done properly or not. So before anode fixing all those things, before doing any repair work, surface preparation. Please kindly notice this word, surface preparation. Surface preparation for any kind of repair work is very, very, very important to ensure a good quality of repair work. So sometimes it has been seen that we are not giving enough patience to come up with a good surface cleaning process or surface preparation process. Because if the tie wires here in this case, if the tie wires doesn't touch to the actual surface of the steel, it won't work. If it touches on the rust surface, it won't work properly, and ultimately you will say that the technology is not good. So be sure that there is a proper connection with the anode to the reinforcing bars or the steels, and the proper cleaning has been done very nicely. You can see here in the this picture, the point I am pointing this picture with the red pointer. They have made these. This is also not a good practice here. This is also not a good practice. Here you can see they have cleaned the that reinforcing bars very nicely before installing the anodes. So now one thing, so this is one that cathodic protection and one is cathodic prevention. So prevention is when we are installing all those things at the very early stage of construction, at the time of construction itself. So we are installing these things, we are preventing the bars not to corrode. And protection means once the steel surface or the steel starts corroding, at that time if you do something, this happens as a protection method. Okay. So now you can see here some of the poor practice they have adopted. You can see here in the top left picture, I have that marking is also the round mark. This is hanging. The sacrificial anode is hanging from the bar, and which will not work. The proper tying was not done, and it will ultimately it will not work. This technology will not work. Here also in the second picture you can see that round I have the mark is there. You can see here exactly at this point. Again I want to spotlight. You can see here there is a gap actually. If you see very clearly, you will find a gap so the purpose of introducing these types of technology has not served in these particular examples. So the structures won't, the system won't work. Here also you can see it should, the tie wires of the anode should get that connected to the bar, and it should be ensure that the tie wires also should not get corroded. If it get corroded, it will break like this. If the tie wires get corroded, so in most of the cases we are installing this anode inside the concrete surface, not outside the concrete surface. Installing anode outside the concrete surface is not good and it won't work. So these are all some poor types of poor practice, poor workmanship. So I have given some examples. So after that, people will say that the technology is not good and it's not working. So it's not like that. So kindly make sure of all those things before installing or before adopting such types of technologies. So now we'll see the next thing. These are some of the step-by-step process for installing that cathodic protections. You can refer all those things later. So coatings, if we say about coatings, there are a number of coatings are there: paintings, polyurethane coating, epoxy coating. So lot of coating systems are there, and we should ensure that for what purpose we are giving the coating, and what is the environmental conditions that the coating is going to face. And this is very, very important. We have to study all those things. We have to do enough homework before selecting a coating materials. And coating is something that in most of the case, coating before giving the coating, the surface preparation is quite important, because if the surface preparation is not good, there won't be any good bonding with the coating. Coating may be anything. It may be paint, it may be different types of laminates, it may be patching work or whatever. So the surface preparation before coating is quite important to achieve a good bond. Now we will come for the mineral admixtures. The mineral admixtures in India, we used to say it is a mineral admixture. But if you go abroad or outside the boundary of our country, there is a special name for all those things. It's known as supplementary cementitious materials, which is known as SCMs. Supplementary cementitious material. Okay, so we'll see a lot about, very brief about this. So these are a very fine ground materials which are having pozzolanic activities, and we are using these types of SCMs for the presence of amorphous silica in between them. So the reactive silica, what you call as. So some of the examples are fly ash and that metakaolin, rice husk ash, the sugarcane baggage ash. A lot of that SCMs are now available, and you can see thousands of research works, thousands, also as a very less number I told. If you see lakhs and lakhs of research works across the globes are there with different types of that fiber induced concrete and with SCMs and all. So these things, a lot of theory are there. You can refer all those things later. I want to show you how these SCMs helps us in the pozzolanic activity of the concrete. You can see here. So, so here, this is the Portland cement hydration reaction. C3S plus C2S with water. When the pozzolanic materials of the cement reacts with water, due to this hydration, calcium silicate hydrate, CHS bond or the gel is formed, which is known as the binder. Due to this CSH, that calcium silicate hydrate only, we are achieving the binding properties of the cement, and with this extra calcium hydroxide is also forming. So now this extra calcium hydroxide, what is there in this Portland, or ordinarily Portland cement reaction product, this product will react with the amorphous silica which is present in that SCMs, and this will react with this calcium hydroxide. With the presence of water, it will again form more CaSH. So the bond will be enhanced, the porosity will be enhanced, and the density will be increased. So this is the main reason we are using SCMs. And SCMs are something by which we can use, which we can replace some amount of cement also. So in conjunction of cement, we are using this SCMs. So this is the mechanism that happens when we use SCMs or that supplementary cementitious content inside a concrete system. So now section enlargement, if you see section enlargement, there are different types of methodologies that we are going to see. I told before itself, it's a subject that we are the whole subject of repair and methodology of concrete and steel structure. The section enlargement is some of the examples I have given here. You can see the top left is that enlargement of that slab, and this is the enlargement of deep beam, and even in some of the wall also. Actually, this is the deep beam. You can see some tendons also has been they have given. They have given some tendons also. I want to show you. See here, the pointer, these are the prestressing tendons that they have, these are the profile, then again it will go up. So these are the profile they have followed for prestressing tendons. They have given externally prestress. Now they will either do some macro concreting or they will shotcrete this area for covering up all those things. So this is also known as section enlargement. So here they are doing in the last picture down, right last, you can see they are doing some enlargement work in beam. From this picture, I want to tell you something. When you are going to do some repair work, undercut is very, very important. So we should, if you do some patching work, you should not just remove the top surface of the concrete, do some cleaning and patch. No, we have to remove the entire contaminated concrete. We have to remove the entire contaminated concrete. So now how to know that how much portion the concrete gets deteriorated? So for that, the different types of tests are there. We should be very patient before adopting any method. So we have to do all those tests. We have to take a lot of core samples from different areas. We have to see what are the different deterioration mechanisms that are that are happening inside the concrete system. So undercut, why undercut is important? Because undercut means somewhat deep after the reinforcing also. You can see here very nicely that the shadow of the bar is coming. So there is a gap in between the bar and the concrete. So undercut is very, very important. So if you don't do undercut, the whole rust of the concrete of the steel, you cannot clean the entire surface of the steel very nicely if you don't do the undercut. And even there are stains on the concrete as well. So the preparation of surface and all those things is very, very important for getting a quality repair work. So it's not possible to go in detail. I have given a very brief, very, very brief idea of section enlargement. It's a different story. It's a different, if you see, it's a different big ocean of section enlargement. How to different types of protocols, different types of things are there. How to do? We cannot adopt the thing as what we want to do by our own wish. So based on the structure, based on the space, based on the different constraints, we have to adopt different methodology of section enlargement. So if it is possible, in one more video, I will show you some interesting methods or interesting process by which we can do the different types of, but which we can undergo different types of section enlargement process. So now you can see that this is also one more, the last one, that FRP based technology, fiber reinforced polymer based technology. This is also one type of a new technology that are coming nowadays in most of the repair work, because in general repair work, if you see that these types of repair works, that heavy workmanship is required, and you have to stop the usability of the structure, and heavy machinery is required. Lot of since you are enlarging the structure, the dead weight or the self weight of the structure also may increase. So the design of everything should be enable of taking all those extra loads. So a lot of hectic processes are there to remove all those things, or to get out from this reed. Nowadays that FRP based technologies are very, very important. And in most of the cases, if you see one case in Pamban Bridge also, they have did some repair work by using FRP technology. I'll show you some pictures as well how the things are doing. So in FRP based technologies, we are using FRP laminates, fiber reinforced laminates. These are the composite structure with a very, very high tensile strength and with a very good elastic properties. And these may be different types of FRPs are there: glass FRP, carbon FRP, aramid FRP, basalt FRP, and in most of the cases nowadays, people are using natural FRP, the polymers also, natural FRP based these things inside the concrete mix to improve the mechanical properties of the concrete. So these are some of the technology. There are some pictures, if you can see that these are the FRP they have used. I'm showing you. So these are the FRP here they have used to strengthen the beam column joint. Here you can see very nicely they have used this. And here you can see in the second picture they used this FRP technology to increase the flexural strength of the beam, as well as since it has been given to the this pillar for this kind of beam and this beam, it will increase the shear capacity as well also. So since it is given to the end of the beam, it will also help to increase the shear capacity of the beam as well. So in the third picture, you can see that both flexural and compression, retrofixation or that strengthening has been done by using carbon fiber laminates. Okay, So now in Anand Institute of Higher Technology, the Department of Anand Institute of Higher Technology also developed some that strengthening models by using aramid and carbon fiber. So in that, I only did these things in the Department of Civil Engineering of Anand Institute of High Technology. We have arrived that different that wrapping and application process of FRP in short columns, hollow columns. These are the steel columns you can see. Actually, these steel columns I am showing you. These steel columns will be actually is like it was fully rust. It was fully rust before the surface preparation has been done. This after preparation of the surface, these columns are looking like this, and after that, it has been wrapped with different types of FRPs. After that, it has been wrapped with different types of FRPs. Here in this project, we used that aramid fiber, the yellow color fiber, you can see. And after wrapping, it has been seen that significant increase in the load carrying capacity has been observed, and it really serves the purpose of applying this FRP. So here we have used both that you can see here the glass fiber also. That glass fiber surface mat has been used to avoid the galvanic corrosion. So in the case of aramid fiber, there may not be any chance of galvanic corrosion because aramid it doesn't have any chemical, or it's very inert to the steel structure. So it's not, so for the safety purpose we have given. So these are the samples here you can see in the right end, right side. These are the pictures that you can see after the wrapping or after the process of the test the samples. So you can see then you can get even this the buckling happens, but the FRP was intact. There is no crack in between the FRPs. So FRP can give a very good repair work. It can serve a very good repair work process, and it can also increase the strength of the structural element very significantly, quite significantly. So now you can see here, I told you that surface preparation is very, very important. See that how much of rust that we're going to that is coming out from the sample or once it has been that blasting with the sand or sandpaper blasting, and then to remove all the impurities we have to clean this surface with that acetone. So you can see the difference. This is the difference after that rust, after all the rust has been removed. You can see here that how much rust has been removed, and this has been done with the sandpaper, and after applying acetone, how much fresh the surface is and how much suitable now it is to apply the thing. So in the case of when we're going to apply some FRP, we have to glue the FRP by using some gluing materials or bonding agents. What we can use to say is that in some of the cases we used to use some resins, epoxy resins or different types of resins we are using with the hardener. So we have to make a proper mixture of hardener with the resin with a proper proportion for getting the good polymerization, for getting a good bond as well. So you can see that how the students of Anand Institute of High Technology, Department of Civil Engineering are performing this activity very nicely. They did, and they come up with a very good surface preparation before applying the that FRP. So the next slide you can see how it looks like after applying. So this was just after applying the FRP. So these are the carbon fibers. You can see here, these are the carbon fibers that we have used for this project. These are 30 centimeter sample only, just to see about the behavior of the fibers, how it works. So different types of fibers will behave in different way in the load carrying capacity. So these are the unidirectional fibers, and we have used these fibers towards the direction of the application of load. The orientation of the fibers was towards the application of the load. So to study particularly this property, we have casted some 20 samples in our lab, and these are some of the samples you can see here. So due to lockdown, the test is still now we didn't perform the test. The casting has been done. So, and one more thing is that there won't be any further corrosion due to the presence of all these polymers and the resins in the metal. So this is a good thing. So we can use this sample after the things when it will get over for doing the test, and at that time we'll see how it behaves. So here you can see in the top and bottom, it was my suggestion to the students to go for the top and bottom, because already the sample height is very less, and when we used to give a load, and the load, the pressure will be very much more in the bottom surface of the column, or of the pedestal or the cylinder. So we can, if we retrofit the top and bottom surface, it may help the sample to take more load. So even it is also somewhat economic, because we didn't provide anything inside in between the that pedestal. What you can see there, for in the case of long column, you can see, in the case of long column you have to provide like this only, or like this what we have adopted here also. But in the case of small pedestals or cylinder, just for experimental purpose, we have casted this sample in such a way to see the behavior of all those things. So this at the left side picture is just after the application of the, you can see the glazy appearance, just it was applied, and it is after 1 day. So this FRP has become very sharp and metallic after getting polymerized 1 day polymerization. So the main you have to wait for 1 week for dry air curing for getting a proper polymerization reaction in between the FRP technology. So these are some of the models that has been developed by the students of Civil Engineering Department of Anand Institute of High Technology. So so these are the technologies, some of the technologies that we are going to use for strengthening process. So this was a very brief discussions of this module. I hope so you got some minimum that information from this. It's not possible to go in detail about all those things in one video. So in future we'll try to create some webinar in some particular topics of all those things, and we'll share all those things in the group. You can see, and hope so you enjoyed these things. And these are all the references I have used. I want to mention one thing in this reference is the most of the that information has been collected from the NPTEL course Maintenance and Repair of Concrete Structure by Dr. Radhakrishna G. Pillai, IIT Madras. And these are the papers that we followed. I followed to prepare this presentation. So these are the references. So thank you for being with us at the end of this webinar, and I hope so it is very important, and I hope so it's very useful for you people, and you got some information, and we can come up with also some good video in the future as well. So be safe, and want to again I want to at the end I want to paid a sincere thank to our management for making this session and this webinar very successful, and for creating such initiative, for taking such an initiative for the students as well as the learners, those who participated in this webinar, for making this session very useful. Thank you, and see you in future. We'll do this types of webinar again, and we'll share all those things in the WhatsApp group. Be in the WhatsApp group up to the end of the seminar, up to the end of the webinar, to get the certificate. Don't leave the group before getting the certificate. What the plan is, we are planning to conduct one assessment exam. Those who will conduct, crack the assessment exam with 80% of mark, for them we provide hard copy of the certificate once the lockdown get over. And those who are for all the participants will provide e-certificate or the soft copy of the e-certificate in the WhatsApp group or in their respective mail IDs. From there they can download the that certificate from the group or from the mail. And those who are participating in the exam, it's my request to everyone to see the videos in the link and to participate there in the exam, to write the exam. It's like a Google form only. You can easily participate in the exam. And those who are cracking above 80%, for them we will provide hard copy of the certificate. Once the lockdown gets over, we'll provide to their postal address. We'll send the certificate. Thank you. Hope you are doing good. You are safe, and all the very best for your future.